Hi there, this is Mrs. Often, and in this series of videos, we're going to discuss triangle inequalities. This is a pretty long slide deck that goes with this lesson, so I have split it up into 3 shorter videos. Our objectives over these 3 videos are to be able to apply inequalities in one triangle, smallest side to smallest angle, and the triangle inequality, as well as the converse of the Pythagorean theorem and ergolo, and to apply inequalities in 2 triangles. So by the time you finished watching this little video series, you should feel comfortable and confident in doing those things. Let's get started. A reminder of the properties of inequality. We have the addition property and the subtraction property that work pretty much the same as they do with the properties of equality. However, with the multiplication property and division property of equality, you do want to recall that if the value that you are multiplying or dividing by on both sides of the inequality is a negative value, then the inequality symbol will be reversed. The transitive property also applies. And the comparison property states that if we add a positively valued quantity to A, when A plus B is equal to C, then A must be less than C. So thinking back to the isosceles theorem and its converse from our last unit, that theorem told us that if a triangle had 2 congruent sides, then it must have 2 congruent angles. And conversely, if a triangle had 2 congruent angles, then it must have 2 congruent sides. This is also known as the base angles theorem. So what happens if a triangle doesn't have any congruent sides? Can it have any congruent angles? Well, we know that all equilateral triangles are equilateral, and it would seem that if a triangle is scalene, it would have all different angle measures. So if there's not any congruent angles, how can we figure out which angle is the largest? Well, the positions of the longest and shortest sides of a triangle are related to the positions of the largest and smallest angles, and that's summed up in 2 triangle inequality statements. These theorems state that if 2 sides of a triangle are not congruent, then the larger angle is opposite the longer side. And you see an abbreviation for this. In a triangle, larger angle is opposite longer side. Here in our picture, AB is of greater length than BC. Our conclusion, therefore, would be that C is of greater measure than A, because C is across from or opposite the longer side. Now, the way I remember this is if a triangle is ABC, if AB is the longest side, then the letter that is not included in the name, C, is the vertex of the angle that is the largest. Similarly, BC is the shorter side. The vertex of the angle would be angle A. Now, if you're dealing with multiple triangles that are kind of stuck together, you do want to be sure that you name these angles with 3 letters. This also works in converse. If 2 angles of a triangle are not congruent, then the longer side is opposite the larger angle. So we have the measure of angle Z is greater than the measure of angle Y. Well, that tells us that the length of XY, the side opposite angle Z, is greater than the length of XZ, the side opposite angle Y. So let's order our triangle side lengths and angle measures. We're going to write the angles in order from smallest to largest. You do want to be careful here and read the directions. Sometimes it will say largest to smallest. Sometimes it will say smallest to largest. Sometimes it will just ask you what the largest or smallest angle is. So be sure to answer the question that's being asked. And be sure to use correct notation. When we're writing these comparisons, we're talking about measure. So by measure, my smallest angle is going to be F, or GFH. My angle of medium size is going to be angle H, and my largest angle is going to be angle G. I want to note that I have measures of all of these angles that I am comparing. The measure of F is less than the measure of H is less than the measure of G. Similarly, in my next triangle, triangle PQR, I'm given two angle measures here, so I can determine that the third angle measure is going to be 48 degrees. So over here at angle R, that's going to be 48 degrees. So they all add up to 180 degrees. Therefore, R is the smallest angle. So PQ would be my shortest side, followed by QR, and finally PR, the longest side. Because I'm comparing measures, I don't put hats on my segments. PQ is less than QR, which is less than PR. Now, another important inequality is the triangle inequality theorem. And this tells us that a certain relationship must exist among the lengths of three segments in order for them to form a triangle. So it's not just any three segments that can form a triangle. They have to meet certain qualities. And that says the sum of any two side lengths of a triangle is greater than the third side length. So AB plus BC must be greater than AC. Additionally, BC plus AC must be greater than AB, and AC plus AB must be greater than BC. So let's look at these. Can a triangle have sides with the given lengths? Well, if I look at 7, 10, and 19, right away, if I had 7 plus 10, that's only 17. So that is not larger than 19, so that's a no for this one. For my second one, 2.3 plus 3 and 1/10 is going to be 5 and 4/10. Well, that's bigger than 4.6. And then obviously adding 2 and 3/10 plus 4 and 6/10 is going to give me something larger than 3.1. And 3 and 1/10 plus 4 and 6/10 is much larger than 2 and 3/10. So the second one works. So I'm just going to put some little, this is going to get an X. This will get a green check mark. It works. And 8, 13, and 21. Well, this is kind of a tough one. 8 plus 13 is equal to 21, but it is not greater than. So right away, I don't need to do any more checking. This fails. All right, so in this one, I have the lengths of two sides of a triangle are 8 inches and 13 inches. Find the range of possible lengths for the third side. So right here, I know that 8 plus 13 is 21. My third side length must be greater than, or must be less than 21, because 8 plus 13 is 21. It has to be greater than the length of the third side. So that's my first important step. Additionally, some number plus 8 must be greater than 13. When I combine these inequalities, I see that x must be greater than 5, super. X must be greater than negative 5. That's not very helpful to me. So I'm going to throw this one out. So x has to be greater than 5, and x has to be less than 21. Remember, I always have to have positive values for the sides of my triangle. So that one where I have x plus 13 is greater than 8, really not helpful. So my value for x is going to be in between 5 and 21, not inclusive. Let's see. The lengths of two sides of a triangle are 22 inches and 17 inches. Find the range of possible lengths for the third side. So the strategy I use here, if I know them, is I just subtract my side lengths to get an expression for the minimum value. Here it would be, again, 5. x must be greater than 5, and I add them to get my maximum value. Adding these together, I get 39. So it must be in between 5 and 39 exclusive. So the bounds of the lengths of the third side are related to the two known sides. To find that lower bound, I can subtract my two known sides. And to find the upper bound, I can add my two known sides. So here's a travel application: San Francisco, Oakland, and San Jose. Now the range and distances from San Francisco to Oakland, it has to be at least 5 miles, 51 minus 46, but it could be as far as 97 miles, or a little bit less than 97 miles. So I'll allow you to check that out on your own and figure out what the actual distance is from San Francisco to Oakland, because 5 miles is a much bigger or a much smaller distance than 97 miles. Okay, here's a quick check. Let's write these angles in order from smallest to largest, and then write the sides in order from shortest to longest. So take a moment to pause this video, write down your answers, and make sure that they check out. Please notice here, I did not use the inequality symbols, and therefore I did not use the measure symbols, and my segments are all wearing their little hats. Another quick check, our range of possible lengths for the third side, whether a triangle can have sides with lengths 2.7, 3 and 5/10, and 9 and 8/10, and explain. And can we have an 8-foot, 6-foot, and 10-foot triangle? Again, pause for a minute and see if your answers agree with mine. And that's it for this video. Thanks so much and have a great day.